a little bit more about me. So yeah, Graeme Antrobus. I am, like to say, the EMEA sales engineer for NTT Data, because I am the only one in Europe, and I cover all bases for our support for our customers and sales team. If anyone, I imagine a lot of people are familiar who NTT is and NTT Data, but for anyone who isn't, NTT Global IP Network, which is the division that I work in, is very much a small band of individuals. There's about 280 of us in comparison to the 56,000 in NTT Data and the 330,000 that are in NTT as a whole. And we are specifically focused on the wholesale IP transit, layer 2 POP to POPs, layer 2 POP to cloud services, and alongside that we've got our DDoS protection services. So if at any point this during your last day at Netnod you'd like to explore any of these, then please do come and see myself or my other two team members, who I've just noticed is one of them standing at the back there, giving me some moral support, because while this is not my first time to Sweden or Netnod, it is in fact my first time doing any form of presentation and any form of presentation on this level of on this scale. So today, a little tech talk. So in today's little tech talk, high level, we're just going to have a look at the current threatscape, or at least the threatscape as seen from ourselves and NetScout, who we partner with for our DDoS protection service, predominantly looking at the comparison of attacks and attack trends from the first half of, well, the last threat report that they did, which was the first half of the year in 2024. A slight coverage off of a selection of tools that you can employ into your mitigation strategy, and then at least a small kind of potential solution, or at least one version of a solution. So, right. So, yeah, news feeds are littered with reports of the latest and greatest DDoS attacks, and a selection of which can be seen here on the screen. And while the facts and figures will likely be a little bit different, depending on whoever's compiling the report, the message is basically the same, though. You know, DDoS attacks are dramatically increasing in both frequency and their sophistication. As I said, we've partnered with NetScout for our DDoS protection service. And as such, I was looking at their latest threat intelligence report, which was looking at the first half of 2024. And there has been a significant rise of about at least 30% in volumetric attacks compared to the previous reporting year, and as much as 43% increase in application layer attacks. So a lot of that's been driven. There's been a significant trend in the rise of hacktivism groups who have increased their focus on application layer attacks, such as HTTP GET and post floods, directed towards critical sectors such as banking, financial services, governments, and utilities. And just as a few kind of high-level examples of those, there was a particularly decent attack back in Halloween. So consider the Halloween 2024 attack. So this was considered to be the largest attack ever recorded so far at 5.4 terabits per second, which targeted multiple businesses and caused significant service disruption. Gaming and gambling sectors were not averse to this. They were attacked in August, and there was a series of high-volume HTTP DOS attacks, which generated in excess of about 201 million requests per second, which caused, again, downtime in a number of major service providers who incurred financial losses on that one. In the financial sector, there was a flurry of attacks in the mid-2024, which peaked at about 4,500 attacks per day, which disrupted anything from online banking, transactions, and definitely considered or definitely affected the perception of digital banking. So, for me, though, personally, I am drawn really to the one at the bottom, which says 1111 bot captures 86,000 IoT devices for DDoS attacks. So for me, the reason that's important, or certainly I find interesting, is that it just reminds me that anything connected to the internet, anything that's digital can be exploited. And when I looked into this, I found that pretty much the the 5 kind of IoT devices that I found that were considered to be the most commonly exploited were smart TVs, set-top boxes, the home hub routers that we have in our homes, IP cameras, so thanks to Ring, and other ones are available. And interestingly, but this one worried me actually, because the rest of them are fine. Like, okay, they're just things that we connect to our network. But the last one I found that was IoT connected medical devices, so such as patient monitoring systems and infusion pumps, which I found particularly worrying when you consider the immediate risk to life and humans that could have there. So looking at kind of a regional view of attacks across the globe, DDoS attacks have been captured and had affected over 200 countries and more than 14,000 ASNs. And according to that NetScout DDoS Threat Intelligence Report for the first half of 2024, there were nearly 8 million attacks counted, which equated to about just over a 12% rise compared to the second half of 2023. As we can see here from the stats that I was looking at, we can pretty much see that North America, LATAM, APAC were pretty consistent, but EMEA experienced definitely a rise through the back end of 2024. And while not on here, one interesting stat that I did find was that in 1H 2024, the largest attack by throughput was 342 million packet per second attack, which was using multiple vectors, multiple different attack packets, which unfortunately targeted Germany. And then, being that they're so popular, the largest attack by bandwidth was also targeting Germany in May, which was a single style attack, single vector attack, which at the time was 960 gigs of traffic. Looking more into the more common attack vectors themselves, TCP definitely is the predominant protocol, or certainly was at this point the protocol of choice. Within TCP, we can see on the right that that TCP ACK is by far the most commonly used packet. And obviously most people will understand this, but for those who are unaware, the TCP ACK or acknowledgement is the third or last in the 3 packets used to create a 3-way handshake between receivers. So although in the case of DDoS, the attack server never sent anything in the first place, this does force the attack server to process the packets, and thus not allowing it to process any other existing connections. So looking at the different attacks method of application or reflection attacks versus good old direct path attacks, we can see that the direct path is consistently the favored approach within this trend through 1H24. Where the reflection and application attacks spoof or hijack the IP addresses of the intended victims or victim to have the packet sent to it, the direct path simply just sends packets straight to the attacked destination. And attackers are consistently changing and adapting to the defenses and improvements made by the industry. So as the industry over the years have got more and more knowledgeable about how to deal with reflection and amplification attacks, attackers are tending to switch back to direct path attacks and use it in ways that are allowing packets to appear more legitimate, which is thus making it more challenging to mitigate against. Another commonly used attack is the carpet bomb attack. We've seen, looking at the NetScout data, we've seen a definite 25% increase in that style from 23 through 24. Carpet bombing is just where attackers take, rather than attack a single destination address, they will use a broad range of IP addresses within that network block. So we're trying to maybe get everything within that /24. And then we've got DNS water torture, which is another common attack method. So again, nearly a 20% increase between 23 and 24. And this is just where an attacker sends a huge amount of requests for non-existent or invalid records, which then that proxy server has to send to the authoritative servers, which then process them, send them back, and just flood the system with illegitimate requests for domains that just don't exist. So looking at the duration of attacks in 1H24, there's about just over 4 million attacks were between 5 and 15 minutes, and just over 1 million in less than 5 minutes. So, you know, combined, you're looking at about 70% of the attacks are actually of less than 15 minutes. So, you know, based on this, you know, attack destinations or, you know, networks who rely on manual interventions are definitely going to be a distinct disadvantage to their counterparts who have included any form of automation into their, you know, anti-DDoS strategies and toolset. Looking specifically at our platform, where we do employ automation, which is available for users. You know, we note that the automation is but 98% of attacks are actually handled automatically, which really only leaves about 1% left for that need to be dealt with manually. And you know, our network security team are, you know, a great bunch of guys that are very easily accessible, and they're more than happy to help. You know, before, during, after an attack, you know, and provide advice. So the fact that we can use the automation to handle the vast majority of the attacks does free up our team to help, you know, help clients and customers where needed for these more difficult and time-consuming attacks. And just that bottom, just to highlight the bottom mitigation duration pie chart. So that's actually taken from our own platform. So whereas NetScout themselves, from their own platforms, from globally, we're looking at and saw about 16% of attacks were lasting, you know, less than 5 minutes. We actually see that as about 44% of attacks are less than 5 minutes. So again, you know, relying on manual interventions to be able to capture something that's less than 5 minutes is going to be quite tough. So, you know, not having automation or within your portfolio is definitely going to not help you in the best way. Just moving then slightly on to sort of some different strategies that can be employed. This is taken from the perspective of a tier 1 upstream provider, I suppose specifically. We can use, you know, an individual, or, you know, can use remotely triggered black hole. That just provides the capability to block all traffic essentially to a destination address. But unfortunately, it does take you know, the bad and the good for anyone who's unaware of what RTBH is. Does require, you know, somewhat a little bit of a manual adjustment, but it's, you know, it can be rapidly deployed once it's all been set up. We do have a slight NTT. We do have a slight extension to that, which is the selective black holing, which I think I've got a slide on later on, so I'll maybe cover that off in a bit. But that selective black holing is, you know, best suited for when you've got attacks coming from outside of the region, and you predominantly know that most of your traffic that's sourced inside your region is good. Leveraging access lists. So we have the ability to provide access lists on our network for customers, and we can use them to block some traffic to and from destinations. So a little bit more granular than the remotely triggered black hole. It does require an element of one-time setup, and there is an element of maintenance required once you've got it set up, because you've got to keep up to date with the prefixes that you're advertising, and particularly the protocols that you want to protect yourself against. They are finite; they're not exhaustive in their lengths, so consideration needs to be required in terms of how you build them. And but also, it's not a catch-all. So depending on the access list that you're using, there's still there is still the opportunity for good and bad traffic to be captured. But it is very good at reducing your attack surfaces, so it's very worthwhile knowing of particular protocols that you are not interested, or some of your networks are not interested in doing, and then just blocking them. And then thirdly, we've got the intelligent mitigation. So this provides the capability of being able to scrub traffic, highlight the difference between malicious and non-malicious traffic, but keeping the non-malicious traffic to ensure network consistency and traffic consistency and the smooth flow of traffic. It does require a bit of one-time setup, but depending on your provider, will depend on whether there's configuration required for yourself or whether it's just purely upstream. A good platform will offer some automation. As we said before, with a lot of the attacks being less than 5 minutes, you need a little bit of assistance there to mitigate those attacks. And in testing, we see attacks, or we see detection and mitigation starting within about 30 seconds. Manual mitigation options are great to have because they allow customers to use the mitigation platforms for testing purposes. And preemptively mitigate an attack if they feel like there's enough evidence to turn it on. They're very highly effective for many different services and many different types of attack, but not always will be suitable for some types of layer 7 application, layer encrypted traffic. But they are definitely best suited for maintaining availability whilst you're under attack. There's no one-size-fits-all really, so it's very important to make sure that you're using, combining these tools for the greatest effect. As I said, we've got at NTT, we've got the usual global remotely triggered black holing, but we've got the extension to that, which is the selective black holing. So that means we can restrict traffic or restrict reach to destinations based on country and region. So if we have a firm in Europe who's predominantly receiving good traffic from their customer base within Europe, but then they're getting traffic that's being sourced from outside, then the selective black holing can be used to deny that traffic that's being sourced from outside the region. Obviously, you're going to capture some of the good traffic that's sourced from outside the region, but at least you're going to still allow the vast majority of good traffic to flow through, rather than send everything into a bin, as would happen with global remotely triggered black hole. Use of ACLs to reduce the attack surface is important. It's important to understand which protocols, which destination sources, networks, etc., that need to really talk to each other, and in particular those networks that don't need it. Networks that you've got inside that have no business in communicating, network time protocol or anything. It's important. It'd be very good to use an access list to restrict that type of traffic to those destinations. And then combining it all, layering on top a mitigation solution like protection services, and then that's going to allow to mitigate quite distributed attacks and complex attacks, and then help to keep services accessible even when attacks happening. So, and the last one really, as part of the tool set, is super important, is your team, your individuals. Developing a team that has processes to, good processes to respond to security incidents, making sure that checklists and playbooks are available, making sure that key phone numbers and access to the network is still there even if you're being attacked, so you've got secondary accesses. And then having training sessions and making sure that everyone's tested and trained, and there's, making sure that if you have an access to a portal, your provider's portal, then making sure that the username and passwords are working, because it's not really much fun trying to reset expired passwords when you're in the middle of an escalation. And just moving on to the last part. So, yeah, I mentioned about the different types of black holing service that NTT data offers. So obviously global real time, which is a catch-all. Selective real-time, which allows a little bit more of a fine-tuning of those black hole announcements. These, while sometimes are considered part of a DDoS strategy, for us actually they're just they make up part of the features and functions of the IP transit service. So you don't need a DDoS protection service from us to have access to these, and they're available at no additional cost. Just going to skip forward a slide because I've got these the wrong way around. So for us, we've partnered with NetScout for our intelligent mitigation platform. We're using this Arbor Sightline for the detection and TMS threat management system for appliances for the scrubbing. So they are our devices. We have purchased them. We maintain, build out, maintain, configure, etc. the network. So while it's powered by them, it's entirely us. We've chosen to deploy these into 13 strategically located places around the world. I like to say 5 continents, although for us technically it's 4 regions. But we've covered off Asia, Oceania, Europe, North America, and South America, and to ensure that we can, by having these, by having a lot of the world covered, does allow us the ability to capture that malicious traffic or capture that traffic as soon as it enters our AS2914, and deal with it immediately in region rather than having to backhaul it, maybe up to North America or into Asia for then forwarding or returning that traffic back to its original source region or source country, which is going to incur delays and latency for the customer's traffic. So all of this helps to just keep those latencies down to a minimum. And then just very, very quickly, so as part of our protection services, we've got a number of different kind of flavors, if you will. On the far left, we've got control, which is simply just the access list that we can apply to our network. It can either be one access list that's applied globally, or it can be done on a box-by-box basis. To the right of that, we've got core. That's great for customers who have got their own detection systems and detection platforms, but they need assistance with some mitigation, or maybe they've got their own mitigation platform, and they just need help with a little bit of assistance when they have particularly large attacks. So they can use our mitigation platform as and when they need it. Moving on from that is detect. Again, all the features from the previous tier, but then we've layered on top of that now the ability for customers to actually initiate their own mitigations. We have our own inbuilt in-house DDoS protection portal, which clients can go in and see, drill down into alerts or into mitigations. If they've got an alert and they've been notified about it, they can use the alert to actually trigger the mitigation. They can communicate with the network security team in there as well. But the core detect, we don't use automation on those ones. They're very much manual in terms of the mitigation capability. Once you move into max, that's where our mitigation starts to come in, our automatic mitigation. So identifying that something's happening, automatically notifying the customers if something hits a certain threshold or a certain reason to, we'll automatically reroute that traffic to the scrubbing centers, clean it, send it on its way. This is where the system works fantastically to deal with that just on its own, and leaving our engineers to then support clients who have got huge attacks happening. And then the very last one there, because the first 3 really are designed for customers to protect their own networks, so networks within their own AS. But we've expanded that slightly to the right, so DPS-SP, or SP stands for Service Provider, and that's just gone a little bit further into allowing networks to protect not only their own networks or themselves, but they can protect their downstream customers as well. So any prefixes that we see coming from a downstream AS can be in there, and it's a great tool for clients who wish to white label or white badge the service and leverage the network that we've created and the platform that we've created, but they can use it for themselves, they can resell it if they will, and then we've provided lots of abilities for them to go into the platform seek information on their respective downstream clients in order for them to facilitate billing and things of that nature. Thank you very much. So if anyone has any questions or anything like that, then I will be in the area next door. Please do come and see me or the rest of my team. So, oh, hang on, we do have one question.
Check. Yeah. So you said that customers can send you a bespoke ACL for filtering as long as it's not too complex.
Yep.
Do you also support rate limiting matched traffic rather than completely blocking it?
No, we're at the moment we don't support rate limiting of. Do you mean sort of rate limiting in terms of like the number of packets per second? Yeah. So
or
we're not
bits per second.
Yeah. So we're at the moment we don't support rate limiting. So it's just the black holing service. You know, just it's like an all or nothing. So.
Thanks.
Okay. Oh, hang on. Hello, sir.
So occasionally we get asked to help customers testing their DDoS stuff.
Yeah.
But because we don't legitimately have access to 3 million smart toothbrushes to use as our own botnet, we just can't find a cost-effective way of creating a DDoS attack. How do you test your mitigations?
We work with customers, and so we don't actually have a botnet or anything of that of our own. So we don't actually create any DDoS attacks ourselves. But we will definitely assist the customer who has that ability to generate a DDoS attack. That we would definitely support them, but we don't generate DDoS attacks ourselves. Hi there.
Yeah, hi. You mentioned actually auto mitigation, but how auto actually it is? Like how often you need manually to adjust it to actual attack, or the system actually can act according to attack, to pattern, or maybe to baselines or something?
Yeah, there's as long as it's been set up correctly. So as long as the protection objects have been created with the networks that you want to protect. It is literally fully automatic. You know, the countermeasures that will be used in a particular attack vector or a particular style of attack will cover off the attack. The only other time really that you have to kind of get manually involved is if you feel like there's either there's maybe too many false positives or things aren't quite working. And that's just a phone call into our network security team. Will cover that off. We don't have any tiering structures. We don't have tier 1, tier 2, tier 3 engineers. We have one phone number. You just phone into the network security team, and the individual who picks up the phone will be the individual that is the tier 3 tech support individual who will help you with that problem.
But do systems have some specific features to mitigate in a specific way, depending on actually attack pattern? Because, well, attacks are different.
Yeah, there are countermeasures within the platform that cover off and can identify what type of attack is happening and then apply the correct countermeasures for that type.
Thanks.
Okay.
Do you want to take one more question, Graeme?
Just one more then, yep.
Yeah.
Two short questions.
Okay.
First, do you have like known networks that you're always going to get DDoS from and you filter them already? And the second question, have you started to think about like exchanging your information about DDoS and automation with other tier 1 operators to form like a collaboration between operators?
Good question. Our head of network security, so a guy called Darren Grabowski, he's consistently working with other tier 1s, and he works with NetScout, and they work together collaboratively for that. So there are, in terms of known networks, yeah, my understanding is that there are some known signatures of certainly botnets that are being used. But we tend to predominantly work on protecting sources. Protecting the destinations as opposed to fixating too much on the sources because the sources change so frequently.
Okay. Well, please join me in thanking Graeme for a fantastic presentation. Thank you so much.